So in this video, we're going to try and iterate a complex function. The complex function we're going to try and iterate is z squared plus 1. Now, we're looking for the second, the third, the fourth and the fifth iteration. Now, if you check the link in the description below, you'll see certain rules for shortcuts to try and maybe find the second, third, fourth and fifth iterations. So I'm just going to jump straight into finding the second iteration on this function here. So if we're looking for f2 of z, that is basically f of z. So we're using the rules of f of z and inserting f of z into those rules. So our f of z is z squared plus 1. So that's what we're going to insert into these rules. So basically, when we've got a z, it's squared. So basically what we're going to need now is z squared plus 1 and square that and then add the constant 1. Okay, so now we can just try and simplify this out. Z squared plus 1, if we FOIL that out, we're going to get z to the power of 4. We're going to get two lots of 1 times z squared. So it's going to give us 2z squared. And then 1 FOILed out is just going to give us positive 1. So that's our f2 of z. Okay, so now we want f3 of z. So our third iteration of z. Now one way we could do this is go f of f of z. Or using our shortcuts, we can go f of f2 of z. That would also give us the same answer, and it also could be a little bit easier for us to work with. So in this one we could use the rule of f of z, so use this rule, and in each one we can just insert f2 of z. So we use this rule, and whenever we see a z we insert this. So let's write that out. So then that would give us, so z squared, so we insert that into our z squared. So then we'd have z to the power of 4 plus 2z squared plus 1 all squared. So hence our f of 2z, and then add on the constant 1 because that's the rule for f of z. Okay, now this is going to FOIL this one out. This one could be a little bit more complicated. So let's just write it up so we don't make any mistakes. And then z to the 4 plus 2z squared plus 1. Okay, I'm going to write my answer straight in here. So just this bit squared, and then don't forget to add this constant at the end, 1. So let's distribute z to the power of 4. Let's just distribute this one. So that's going to give us z to the power of 8. 2z to the power of 6. And just 1z to the 4. Now let's distribute this one. 2z squared. So with this one we're going to get 2z to the 6. And this one's going to give us 4z to the 4. And this one's just going to give us 2z squared. Okay, that's that one done. Now let's just distribute the plus 1. So basically that's just going to mean just rewriting out the function. And then, of course, adding plus 1 at the end. Okay, so I'm going to rewrite this out now, getting all the like terms together. Z to the power of 8, z to the power of 6's, well, we've got 2 there and a 2 there. So that's going to give us 4. Then r to the power of 4's, we've got 1 here, 1 here, 1 here. So 1 plus 4 plus 1, that's going to give us plus 6 z to the power of 4. Our z squares, we've just got 2 So that's plus 4z squared. And our constant is just going to give us plus 2. Okay, let's take this off the board and then we'll try and find the fourth iteration. Okay, let's find our fourth iteration. So f4 of z. Now, there's probably 3 ways we can do this one. We can either write this as f of 3z, or we could write this as f of 3 using f of z. So that would be using the f of 3 rule. So use this rule and inserting f of z wherever you see a z. This one would be the reverse, using f of z's rule and inserting f3 of z wherever you see the z. Or you could do f2 of f2z. So again, using this rule and inserting this wherever you see the z. Okay, so I'm going to choose to use this f2 times f2 of z. So let's try that. So we've got z to the power of 4. So wherever we see the z, we insert z to the power of 4. So this one will be to the power of 4. So we've got z to the 4 plus 2z squared plus 1. And that's all to the power of 4. Now our 2z squared. So now we're going to add 2 times z to the 4 plus 2z squared plus 1. And that's all squared. And now we just add on the constant 1. Okay, I'm not going to expand this out. I'm going to leave that for you guys to work that out. But instead I'm going to write out each one of these instead so you can see what will happen. Okay, so f of f3 of z. So that's using f of z's rule and inserting f3 of z. So here we've got z squared plus 1. So we need to insert this one and square it. So that will give us z to the 8 plus 4z to the 6 plus 6z to the 4 plus 4z squared plus 2 all squared plus 1. And now let's have a look at the other way round, which was this one, which is f of 3's rule for f of z. So using this rule and inserting f of z. So z to the 8, we write z squared plus 1 to the power of 8. And then 4z to the 6, 4 times z squared plus 1 to the power of 6. 6z to the 4, 6 times z squared plus 1 to the power of 4. 4z squared. So now I'm going to use the coefficient 4 and z squared plus 1 squared. And then all I need to do now is just add 2. So just add on 2. Okay, now our last one we need to find is the fifth iteration. So as before, I'm just going to show you where you can find that, and I'll let you guys expand this out if you want to do that. So the way I would probably do this is to use the f of 2's rule, because that looks a little bit less complicated than the f of 3, and then stick in f of 3. But you could do that one of the other combinations, so as long as these two units here, the 2 and the 3, or 3 and 2, or 1 and 4, or 4 and 1, whichever way you want to go. Okay, so using f of 2's rule, so z to the power of 4, and I'm inserting f3 of z. So that is what I'm going to insert and raise it to the power of 4. So z to the 8 plus 4z to the 6 plus 6z to the 4 plus 4z squared plus 2. Raise that to the 4. And now I've got 2z squared, so 2 times this and square it. So 2 times z to the 8, let's just make that neater, plus 4 to the 6 plus 6z to the 4 plus 4z squared plus 2 all squared. Then all that's left for me to do now is just to add 1. Okay, and that's my 5th iteration along there. Okay.